Today we're going to talk about the different properties that logarithms have. So logarithms have properties that we can use to expand or simplify or condense their expressions. This reminds me a whole lot of exponent properties. So when I say exponent properties, I mean like if you had an, oops, I don't know why it's doing that. Don't write this down, but if you had like an x3 times an x4, then you know that the property says when the bases are multiplied, we add them, so we get x7. Things like that. So we have talked about properties of exponents. Logs have similar properties, so they're not quite the same. But if we know what they are, then we can condense expressions or we can expand expressions, and then we can do things with them. So it's really all we're doing today is just learning what we can do with the logarithms. All right. So for this first property, it says that if you have log base b of m plus log base b of n, then that really means that you have the log base b of m times n. So if you have the same base and you're showing addition in between the logs, then you can put those numbers together as multiplication. So if I have log base 4 of 2 plus log base 4 of 32, I can say really that is log base 4 of 2 times 32. Oops, not 33, 32. And really, that's log base 4. 2 times 32 is... Oh. I took notes on another piece of paper to make sure I didn't make a mistake, and it was turned the wrong way. Okay, it's 64. Okay, so that's all the property says. If I had this situation, technically now I could solve it. So before I couldn't really solve anything, but now that they're together in one log, now I can solve. So now I can change it to exponential and say 4 to the x power is 64. I know that 64 is really 4 cubed. So I have x equals 3. Okay, if I have log base 6 of 4 plus log base 6 of 54, I can't do anything with that until I put them together into one single log. So I could say it's really log base 6 of 4 times 54, which is log base 6. 4 times 54 is 216. Okay, that's using the property. But now that it looks like that, we could solve it. Because 6 to the x power equals 216. 216 is really 6 cubed. So x equals 3. Okay, if I have log base 7 of 2 plus log base 7 of 171.5, I can't do anything with those logs, the two of them, but if I condense them to 1, I have log base 7, 2 times 171.5. So it's log base 7 of 343. Okay, but now I have a single log and I can solve it. So 7 to the x power is 343. 343 is really 7 cubed. So x equals 3. It just happened that all of these answers were 3. Okay. This property can work both directions. So I just went from addition to the condensed property of multiplication, but I can also expand them. You don't have to expand them near as often as you would have to condense them, but it's still good to know that you can. So log base 8 of 7 times 11, I could rewrite as log base 8 of 7 plus log base 8 of 11. Sometimes in whatever question you're working, if there's a lot of things going on, it's helpful to know how to expand the logs because then you can simplify from there. All right, if I have log 9 times 4, this log doesn't have a base on it. Remember, that means it's an understood base 10, and we don't have to write it. But So, but if I expand it, I still have that log base 10 of 9 plus log of 4. All right, so there's that property. The next property is the quotient property. So very similar. If we add, we multiply. But if we subtract, we divide. Okay, now you need to notice the order. Whatever log is written first, m, is going to be the numerator of your fraction. Whatever log is written second, n, is going to be the denominator. So if I have log base 2 of 32 minus log base 2 of 4, because they're the same log base, I can write them together and say, really, we have log base 2 of 32 divided by 4. Well, 32 divided by 4 is 8. So this is really log base 2 of 8. Okay, well, now I have a single log, so I could solve it. So let's say that 2 to the x power is 8. Well, no, 8 is 2 cubed. So x equals 3. Okay, log base 5 of 100 minus log base 5 of 4. So I have log base 5, 100 divided by 4. Well, 100 divided by 4 is 25. Okay, so that's how I use a property. Now we could practice solving because it's there. So 5 to the x is the same as 25. Well, 25 is 5 squared. So I know that x equals 2. All right, log base 2 of 32 minus log base 2 of 128. So really I have log base 2 of 32 divided by 128. 32 divided by 128 is going to simplify to 1/4. Okay, so now that I have a single log condensed, I could solve it. So 2 to the x power is equal to 1/4. Well, I know that 1/4 is 2 to the negative 2. So I could say that x equals negative 2. All right, now, sometimes it's helpful to also know we can go the other way and expand it. So if I have log base 5 of 3 divided by 10, I can say that's really log base 5 of 3 minus log base 5 of 10. All right, if I have log of x divided by 3, remember that just means the base is 10. I don't have to write it, but I have log of x minus log of y, okay? All right, last property is the power property. The power property says that if you have log base b of a raised to the p power, if you have a power on that number, you could pull it down in front and say that it's really p times that log value. So for example, if I have log base 3 of 81 squared, I could do 81 squared and then try to solve from there, but that's just a huge number. So instead I can take this power, I can pull it down in front and say that's the same as 2 times log 381 equal x. Okay, well now I'm going to take log 381 equals x, I'm going to solve it, and then I'm going to multiply my answer by 2. So don't forget that this is here. All right, so if I take log 381 equals x, it's really 3 to the x is equal to 81. So here we've applied the property, but now we're going to solve it just for good practice. Well, 81 is the same as 3 to the 4th power. So I really have x equals 4, but bring this 2 back. Now multiply by 2, my answer is 8. Okay? Log base 5 of 1/5 to the 3rd. So I'm going to take this 3, I'm going to pull it down in front and say it's the same as 3 times log base 5 of 1/5. Okay, but I'm going to remember that's there. I'm going to figure out what x is and then multiply it by 3. So if 5 to the x power is 1/5, well, 1/5 is 5 to the negative 1. So we can say x equals negative 1, but now we need to multiply it by the 3 that we pulled in front. So really x is negative 3. Okay? If I have a power of 5, I can pull it down in front and say it's really 5 times log base 1/4 of 16 equals x. So I'm going to figure out what x is and then multiply it by this 5. So if I have 1/4 to the x power equals 16, well, we could say this is really 4 to the negative 1 times x equals 4 squared. So I have negative x equals 2. Divide by negative 1, x equals negative 2 times 5. So I have negative 10. Okay, now, here's where the power property can be put into play. We're going to go to that number I told you to skip on your assignment the other day. So in our Intro to Logs assignment, I told you to skip number 34. Some of you did it, and some of you got it right. Very few of you. Some of you tried it. Just because you forgot, you didn't have to do it, but it still wasn't right. You can't do this problem until you know this property, which is why I told you not to worry about it the other day. So this is going to look very like long-winded, but if you just work it back and forth, then eventually you'll get to an answer. So let's work through this one so that you can see what really happens. I have an exponential situation with a log and the exponent. So the first thing I'm going to do is turn it to logarithmic. So I have a base of 9, so log base 9 of the answer of x equals log base 3 of 20. Now, if my logs were the same, then I could take them out and say x equals 20, but they're not. But what I can do is I notice that I have 9 and 3. So I'm going to make them the same base. So I'm going to change this to say it's really log of 3 squared or log base 3 squared of x is log 3, 20. But those logs still aren't exactly the same because one is 3 and one is 3 squared. So I'm going to go back to exponential form. So my base is 3 squared. The exponent is what used to be the answer, log 3, 20 equals x. Now here's where this comes into play. I have 2 now times that log. So it's going to become the exponent of 20. So this is the same as 3 raised to the log base 3 of 400. Now if I turn it back to log form, I have log base 3, this is 3, of x, so of my answer, equals the exponent, log 3 of 400. Now that my logs are exactly the same, I can say that x equals 400. So again, that's kind of long-winded and back and forth, but if you need to understand that when you have 2 times a log, it's not really multiplying it, it is raising it to that exponent. If you have it as the exponent, it can become the multiplier, but you can work it backwards as well. So we just worked that one backwards to help get us what we needed so that we could simplify. Another thing that you're going to see today is ln. Okay, we've been writing log, L-O-G, stands for logarithm, right? ln is a logarithmic function. It is a log, but it's a very special log it's called the natural log. The natural log follows all the same properties of logs. You just write it ln instead. And there's more to do with what a natural log really is, and it will come back up later. But you're going to see it on today's paper. So I just wanted you to know that ln is the natural log, same properties as a normal log.